Hi, I'm here and I'm going to give you a little quick introduction to the force sensitive resistor, and it's a really useful little component. It's basically a variable resistor that changes when you apply different pressure onto the active area, which is the force sensitive ink. So basically, an analogy that I find helpful to understand how these work is if you have a sponge uh, and you fill it up with water, you'll just enough so that the holes within the sponge are still have air in them, then you can only have so much transfer between like one side of the sponge to the other side if you're putting water through it. But if you squeeze the sponge together, then the holes disappear and the actual sponge touches, there's more surface area, and there's no more air inside, then there can be more transfer of the water. It's more solid. And pretty much exactly the same thing with the force sensitive resistor. There is an ink that is sprayed, and when you push down on it, you actually are connecting to two like sets of interlinked fingers. And what's happening is, like the sponge, you got air between the two fingers, which you can see the other lines here. And when you squeeze down, you're actually squeezing on an ink that becomes more conductive the more pressure that's applied. So when you think that that's surrounding these two interlinked fingers, that are not actually touching at all, but when you squeeze in the ink, that become more conductive, then they do actually end up conducting just ever so slightly. And the harder you push, the more that they conduct. And you can push a lot on one side, but it will never saturate unless you push on the entire surface area of the FSR, which is short for force sensitive resistor. And then you can actually get the component to saturate. So just in case you wanted to ever figure out why you couldn't get 100% reading out, it's because you do need to actually squeeze down on the whole area. And because I said it essentially behaves as a variable resistor, you do actually need a second resistor that will match. Usually, it will be given to you, but it will be matched to the FSR total resistance, and you set up the circuit in a voltage divider as a voltage divider, and so that the you can actually fetch the output of the voltage divider um, as an as a variable analog voltage. And I have a sketch on the Tinsy that actually fetches the resistance of this FSR and does the calculations to output a, a semi-accurate reading in grams. And this can be useful in a lot of ways. You can have it as a button, or you can have it as a variable actuating button, so you can have different states, how hard you're pressing. So if you touch it lightly, it does one thing, or harder, another thing. But also, if you look at your PlayStation or Xbox controllers, the buttons on that are they are not binary. When you push down, they will have a variable pressure sensitive uh, output, if you ever noticed, and that is because they actually use the same technology. So you can use it in controllers or anywhere where you need some kind of like human input, not just on off, being clicked, not being clicked. You want how hard is this thing being pushed, um, and yeah. So uh, the sketch that I've got now is again from Adafruit Spark Fun, have their own helpful hookup guides, and I'll link all of that and the eBay listing in the description below. But if I fetch the camera and quickly show you the sketch itself, then you can just see that I tell it where the FSR pin is, and you tell it what your voltage is and what the resistor at the other fixed resistor is, and then there's no library needed for this. It's just quite simple calculations. Here on line 48 to 51, you can see that the only complex thing that they're doing is they're actually turning the resistance into conductance, because it's more linear. When the output is more linear, if you actually graph this, whereas the resistance is more of a curve. When you divide resistance, when you do 1 divided by the resistance, you actually get conductance. That's more of a linear output, so it's easy to just output a number from that and have it more responsive to the input. And so the values on line 38 and 41 are just for the voltage divider that fetches the ADC, and that is pretty much it. And so if I push down on this like so and look at the output on the serial output, you can see that it's actually it's scaled nicely. I'm not pushing it, and when I push it quite hard, it's actually figuring out that I'm pushing down to about 2 kilograms. So, and it is very, very sensitive, these components. And if you want to do quite light touches, you'd need to you need to make sure that the FSR that you get is designed for light loads as opposed to heavy loads. But this one I've got here from 2015 all-in-one on eBay has can fetch really light loads. I mean, I'm trying to put really low pressure on this. I mean, it's fetching about 3 grams. So yeah, have fun with this. You can do quite a lot with it. Um, they're not the cheapest components, but they're really useful, and the quality is really high with these. So have fun with them. You can get them in different forms, factors. You can get them in flat planes. You can get them in squares. You can get them in these little circle coin size, smaller ones, bigger ones. Um, you can get ones that actually have a matrix of these. This is a single zone. You can have one that has an X, Y. And what you can do with that is you can move your finger around on the surface, and it will, because you're fetching each cell, you can know where you are on an XY 2D plane, and when you push down, you actually have the Z axis, which is pressure. So you can do a lot of interesting stuff with that. Cool. So I hope that was interesting, and yeah, have fun with that. Cheers.